All right, so this is the very last problem. Yay! Number 10. In 4 o'clock plants, the dominant allele for flower color is red, big F, and the recessive allele is white flowers, little f. Flower color in 4 o'clock plants is also a incomplete dominance. It should say an example of incomplete dominance, which means when the organism is heterozygous, big F, little f, the dominant and recessive alleles blend to make pink. If one white flowered plant and one pink flowered plant are crossed, what will be all the possible genotypes and phenotypes of this offspring? Now, we haven't introduced this idea yet, so this should be somewhat new to you, and we'll be talking about different forms of inheritance besides dominant recessive in another activity coming down the road here. I think it's 65. So just to kind of let you know that not all traits are definitely dominant recessive, always like that. We're teaching you the most simplistic way first so you can get your feet wet, and then we'll make it harder as we go along. So the key for this is going to look a little bit different. It tells us that big F equals red and little f equals white, which is, you know, kind of a basic one that you've already been doing, but here's where it gets more complicated. The way that we've been learning so far, we have said that if you have a heterozygous big F, little f, that would show the dominant trait red. But in the case of incomplete dominance, as it says here, this is not the case. A big F, little f instead will show a blend of the red and the white. And that blend would be pink. So our key there is a little bit more detailed than we've been doing so far. So the question says, if one white flowered plant, and white's recessive, so we know that that parent has to be little f, little f. If one white flowered plant and one pink flowered plant, and to be pink, you have to be heterozygous, are crossed, what will be the possible genotypes and phenotypes of the offspring? So we fill this out, and it turns out that we won't have any red offspring because we don't have anything that is homozygous dominant. Because in this case, the heterozygous shows pink, not red. So as far as genotypes go, we're going to get about half being heterozygous, and the other half producing white flowers. So phenotypically, we get half being pink and half being white. No red at all.